Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Nader. So I'm continuing my O-level past papers session. This time I've selected CAIE Chemistry 5070, and we have paper 4, that is variant is 41, and it's of May-June 2024. It's of 1 hour. Paper 4 is alternative to practical. You have to answer all the questions, all the answers in the question paper. No additional materials are needed. So you can use calculator in this paper. You can show your working and use appropriate units. Total mark for this paper is 40. Remember, there won't be any periodic table in this paper. You should know that you have to learn first 20 elements. Notes for use in qualitative analysis are provided in the question paper, just like that. You have test for anions, test for cations, test for gases. Last but not least, flame test for metal ions. These will help you in answering qualitative analysis question. So let's start the paper. So here's question number 1. A student finds the concentration of a dilute acid HA aqueous by titration. The student adds 25 centimeter cube of aqueous sodium hydroxide to a conical flask, adds a few drops of methyl orange indicator to the aqueous sodium hydroxide, slowly adds HA aqueous to the aqueous sodium hydroxide until the methyl orange changes color. Records the volume of HA aqueous added. A part 1. Figure 1.1 shows the apparatus the student uses to measure 25 centimeter cube of aqueous sodium hydroxide. Name the apparatus shown in figure 1.1. You know that's measuring cylinder. So we will write measuring cylinder here. Part 2. Name a more suitable piece of apparatus to measure 25 centimeter cube of aqueous sodium hydroxide. So here we are having fixed volume of sodium hydroxide. So in this case, you are going to use volumetric pipette. Figure 1.2 shows the apparatus used to determine the volume of HA aqueous at the end of the experiment. Name the apparatus shown in figure 1.2. Now see, this is the burette. It's also used in titration. It's burette. The initial reading on this apparatus is 1 centimeter cube. Use figure 1.2 to determine the volume of HA aqueous used in the titration. If you look at this, you must be having 23. 1, 2, 3, 4, 5, 6. Must be 23.6. 23.6. B. The student washes the apparatus in figure 1.2 before it is used. State the substance used to wash the apparatus. So what is added in 1.2? HA is used. So we will use HA to wash, which is the acid, to wash the apparatus. C. Describe the color change of methyl orange at the end point. So initially the color must be in alkali. You are adding acid to this alkali. So what will be the color of methyl orange in alkali? It's yellow. And as you have added acid, the color will change to red or pink. So here's question number 2. A. A student investigates the reaction of 4 metals A, B, C, and D with aqueous copper 2 sulfate. The 4 metals are all gray solids. The student puts 25 centimeter cube of aqueous copper 2 sulfate into a beaker and measures its temperature. Records this temperature in table 2.1. Adds a sample of A to the aqueous copper 2 sulfate. Stir the reaction mixture until there is no further increase in temperature. Measures the highest temperature of the mixture and records the temperature in table 2.1. Observes any changes in the appearance of the mixture in the beaker. The student repeats the experiment 3 more times using B, C, and D instead of A. Results for D are shown in figure 2.1. So here we are having results for T, initial temperature and highest temperature. The result for A, B, and C are shown in table 2.1. Table 2.1. Number 1. State the value in table 2.1 which the student records to an incorrect degree of precision. So if you look at the values, definitely this must be the incorrect value. You can't have 20 degrees centigrade. You must have value after decimal for this 20. So I will write 20 here. The incorrect. Number 2. The temperatures for D are shown in figure 2.1. Record these temperatures in table 2.1 and calculate the record and record the temperature increases for B and D in table 2.1. So for B, we need to subtract 24.5 from 46. 46 minus 24.5, get 21.5 for this one. What about readings for D? So initial temperature, it's 21. If you look at this value, it's 21. What about the highest temperature? It must be 53.5. Subtracting these values, 53.5 minus 21, you will get 32.5. Moving to the next part, which is part 3. The equation for the reaction between B and aqueous, aqueous copper 2 sulfate is shown. B solid plus CuSO4 aqueous gives BSO4 aqueous plus Cu solid. Copper 2 sulfate is a blue solution. At the end of the experiment, the student observes a colorless solution, a gray solid, and a brown solid. Explain how these observations show that B is in excess in this reaction. So if B is in excess, definitely there will be some amount of B will be left in the solution. So you see, if in the question, they have already mentioned that these metals are all gray solids. So you must be having gray solid left at the end of the experiment. So you can say gray solid left or remains, which shows that B is in excess. Part 4, using the equation 3, write the formula for the colorless solution, the gray solid, the brown solid. colorless solution, it must be BSO4. Gray solid, which is left, it must be B, as I've already told you that gray solid will be left or remains because it is in excess. Brown solid, it's of copper. Copper excess, brown in color. Part B, use your results to arrange A, B, C, and D in decreasing order of reactivity. Explain how the results give this order of reactivity. So we have most reactive and least reactive. How we are going to arrange this? Looking at the temperature change. If you look at the temperature change, which of these having highest temperature change? It's A. Highest A. So I will write number 1 here. Second must be C. And third is D because having 32.5. Fourth must be B. So it must be A, C, D, B. Highest to lowest. A, C, B, D. A, C, D, B. A, highest temperature change. C, D, B. Now explanation. For explanation, you will write the greater the temperature change, the more reactive the metal. More reactive the metal. C. A student repeats the experiment using a fifth metal. This metal is the second most reactive of the 5 metals. Suggest a temperature increase for this experiment. Now they are saying it must be second most reactive, which means it must be less reactive than A and more reactive than C. So we'll look at the values for A and C. So for A and C, we are having 39, 40. So it can have any value between 39 and 49.5. Any value between 39 and 49.5. D. The temperature increases measured are less than the true values for these experiments. Suggest a reason for this. Describe an improvement to the method which makes the results closer to the true values. So definitely it must be loss of heat to the surrounding. In order to avoid this, we can go for polystyrene beaker. Polystyrene beaker. Or you can have more insulation. Party. State and explain the effect of using half the concentration of aqueous copper 2 sulfate on the temperature increase for metal A. So definitely if you are having low concentration, it will give lower temperature change or rise. And this temperature change will be reduced to half in each experiment. Then will be temperature. Change will be reduced. We are not having definite values, so we'll write approximate. By half. Each experiment. The reason is that you will be having fewer copper ions, or you can even say that you are having half the number of copper ions to get, or half the number of copper ions to react. Next question, which is question number 3. A student does a series of experiments to investigate solution R. A. The student leaves a wooden splint with one end dipped into R for 10 minutes. The student then places a damp end of the wooden splint into a blue Bunsen burner flame. The flame briefly shows a shade of red and then turns yellow. 1. State 2 possible conclusions from this observation. Shade of red and then turns yellow. They are saying shade of red. They are not saying red. Shade of red and then turns yellow. So yellow must be of the flame. So you can't have sodium in this case. Now they are saying shade of red. So you must be having Li plus. And when they are saying shade of red, the color that comes near to red must be orange. So it must be having Li plus and Ca2 plus, not Na plus. So you can write may contain Li plus and Ca plus 2. Explain why it is difficult to make a definite conclusion from observation in A2. Because the reason is that these are different ions, they give similar colors. These two ions, in case of Li, you are having red, in Ca, you are having orange red. So you write different ions give similar colors. B. The student adds dilute nitric acid to R followed by aqueous barium nitrate. The student concludes that R does not contain sulfate ions. State the observation which allows the student to make this conclusion. So if you look at the test for sulfate ion, look at the test for sulfate ion, where is sulfate ion? It must be among negative ions, that is anions. Anions are negative ions. So here's sulfate. You see, if you have to acidify with dilute nitric acid, then add aqueous barium nitrate must give white precipitate. So it's not giving white precipitate. So you'll write no change. That's why the student made this conclusion. Part C. The student adds dilute nitric acid to R followed by aqueous silver nitrate. The student observes a white precipitate. State the conclusion from this observation. If you look at the list, nitric acid and aqueous silver nitrate, you are having chloride, bromide, and iodide. And chloride is the one which gives white precipitate. So, the conclusion shows that it must contain chloride ions, Cl minus or chloride ions. D. The student adds aqueous silver nitrate to aqueous sodium carbonate. A white precipitate forms. The student adds dilute nitric acid a drop at a time until no further change is seen. The white precipitate dissolves to form a colorless solution. 1. Describe one other observation. So you are having sodium carbonate and acid reacting. There must be fizzing. There must be fizzing, or you can say bubbles, due to the formation of carbon dioxide. Fizzing, bubbles. You can even write effervescences. Number 2, suggest why it's important to add dilute nitric acid in C. You see, the function of nitric acid here is that it destroys any carbonate present. Because this will also give a white precipitate. So you can simply write, we want to distinguish between these chloride ions and the carbonate ions. That's why we are adding this nitric acid. So you can write distinguish. Otherwise, it will mask the original color of the ion present in the solution. Pure negative and carbonate ion. Party. The student adds a few drops of aqueous sodium hydroxide to R. State the observation that student makes, which suggests that R may contain Ca2 plus. Now here's the test for the cations. Cations means positive ions. If you look at the test for cations, that is for calcium Ca2 plus ion with aqueous sodium hydroxide, it's giving white precipitate which is insoluble in excess. So I will write white precipitate. You will only write white precipitate because they are not asking the observation in excess of sodium hydroxide. F. Describe what else the student needs to do to confirm that Ca2 plus ions are present. State what the student observes. And so what you can write, you can even write now, you can write further in excess, white precipitate remains, which means insoluble in excess. Then you have the test with aqueous ammonia, which is no PPT or very slight white PPT. So if you want to write test with NaOH, the test and observation will be white precipitate remains. Now, if you want to write with ammonia, test with aqueous ammonia. Here you have test with the excess NaOH, not only NaOH, because they have already mentioned the test with NaOH. Here you will write excess NaOH. Here white PPT remains, and test with aqueous ammonia, no PPT. No PPT or slight, very slight white PPT. You look at the test, you are having very slight white PPT or very slight white precipitates. G. The student warms the solution from E. The student concludes that ammonia gas is produced. Now the student warms the solution and student is also concluding that ammonia gas is produced. Part 1, state the observation the student makes, which confirms that ammonia gas is produced. If you look at the list, here we are having ammonium ion and it produces ammonia on warming. How do you know that? We look at the test for gases. Here the test for gases, ammonia, gas ammonia. It's turning damp red litmus paper blue. So it is a test that confirms that ammonia gas is produced. So you write test for ammonia gas. Test for NH3 gas. So gas turns damp or moist, damp, red, litmus paper, blue. Number 2, identify a cation other than calcium present in R. Definitely looking at these observations, it must be NH4. You see here, test in the cations, Na plus, it's producing ammonia on warming. H. Solution R is made from a mixture of two different ionic compounds. Suggest the names of these compounds. So far we are having these ions. We got, I'm talking about R. So we have Ga plus 2 ion, ammonium ion, and Cl negative ion. So you can have the compound with calcium chloride. It must be calcium chloride. And the other must be ammonium chloride. These are the possibilities. Next question, which is question number 4. Also the last question. Barium carbonate decomposes when heated. The word equation for the reaction is shown. Barium carbonate gives barium oxide plus carbon dioxide. Plan an experiment to determine the percentage loss in mass when barium carbonate is heated. Your plan must include the use of common laboratory apparatus and a sample of barium carbonate. No other chemicals should be used. Your plan includes the apparatus needed, the method to use, and the measurements to take, procedures to ensure that the percentage determined is as accurate as possible, how the measurements are used to determine the percentage loss in mass. So you'll have, let's see, you may draw a diagram to help answer the question. The total mark for this question is 6, and they gave space also for the diagram. And what diagram you can include here? So you'll be definitely having heating apparatus for heating the solid. So you will get 1 mark for this. 1 mark for this heating the apparatus. So you can have Bunsen burner like this. You can have tripod stand. Bunsen burner. 1 mark for this. What else you can write? Now they are saying method. What method you are using? So first of all, definitely, now here I'm going to write method. It's of 6 marks, so you can write any 2 points from this method. Then you will write the I need 2 points for accurate measurement. 1 mark will be left. What we will do? We will write the formula for calculation. So I need two for this method and measurement. Method and measurements. I need two from this. So what you will do? You have to measure the mass in the beginning. Measure the mass of sample. You can even use weight. And you have to heat the sample. Because you want to check the loss in mass when it is heated. The container, you can name the container like crucible. Then you can have reweigh after heating. Reweigh after. So they are saying procedures to ensure the percentage determined is as accurate. Now they are saying talking about accuracy. So for accuracy, again you have any 2 points from this. Heat again or reheat. Heat again or reheat. Measure mass again. So for accuracy, we repeat so that we can take the average. Repeat the procedure, repeat the experiment. Take and average. What else you can write beside taking average? We are testing the reliability or testing the reliability of this experiment. Testing the whether it's reliable or not. Reliability of the experiment. You can even write or to identify anomalies. What does it mean? Anomalies means some irregular or unexpected values in the experiment. We have to avoid this. Huh? So you have to identify this. Last thing, calculation. Remember, write the calculation. This will give a very good impression. You will gain the full mark for this. How you're going to do the calculation? So what you will do, you will subtract the initial mass from final mass. So you write final mass will be subtracted from initial mass. So you have initial mass minus final mass and divide this by the initial mass of sample. We are calculating the percentage, so you have to multiply it by. This will be the complete and final answer for this 6 marks question. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.